welcome to Math After Hours. So the homework we're looking at today is 7 through 14 that deals with the properties of parallelograms. So before we get started, I want to make sure we all know the properties of parallelograms. So remember, by the definition, a parallelogram has two pairs of opposite parallel sides. And then also the opposite sides are congruent, opposite angles are congruent. The consecutive angles, so the angles that are right next to each other, are supplementary. Remember, supplementary means that the two angles add to be 180. And then also the diagonals of the parallelograms bisect each other. So the ones that are the most important to know are these four right here. Those are the ones we're going to use the most often. So let's start with number 7. So number 7, if you look, it's talking about our sides here. So we have side LM and side PN. So the sides are opposite from each other, and the property for parallelograms are that opposite sides are equal. So since these two sides are equal, we're going to set these two expressions equal to each other. So I'm going to say 9x minus 25 equals 5x plus 7. And then we're going to solve for x algebraically. So remember, you can always pretend there's a brick wall down your equal sign. So when we combine like terms across that brick wall, you always want to do the opposite. So the opposite of a positive 5x is a minus 5x, or subtracting a 5x. So then 9x minus 5x gives me 4x minus 25 equals 7. And then you want to combine your constants. So I'm going to add 25 so that I get, so then I'm going to get 4x equals 32. And then you just want to make sure that you divide by 4, since you're multiplying 4 by x right here, divide by 4. So then we get that x equals 8. You always want to make sure you answer the question it asked. It said to solve for x, so we're good. We got x equals 8. So for this one, we used the property that opposite sides are congruent. 8's going to use that same property. So wx, this side right here, is opposite dy, and those are the two sides where the expressions are written. So the setup is the exact same. So since the opposite sides are congruent, I'm going to set those two expressions equal to each other. And then solve algebraically. So then I end up getting x equals 4. Now again, you want to make sure you answer the question that I asked. It said to find yz, so we have one more step we still need to do. So we got x equals 4. So to find yz, it tells us that it's 19x minus 31. So I want to substitute 4 in for x. So I'm going to say 19 times 4 minus 31. So 19 times 4 is 76, minus 31 will give you 45. Okay, so then it's telling you the length of zy, or yz, is 45. So that's how we found problems 7 and 8. So for both of these, you use the property that opposite sides are congruent, and then we set the expressions equal to each other. So let's move on and look at 9 and 10. So 9 and 10 deals with the diagonals. So if you remember from the properties, the diagonals of parallelograms bisect each other. So bisect means that it cuts it in half. So each part of those diagonals are going to be congruent. So like here, TW would be congruent to WV, and then SW would be congruent to WU. So for this problem, just going to erase those marks so we can see a little bit better. For this problem, it says that TV, so this whole thing here, equals 74, and then WV, so half of it, is 4x plus 1. Well, if the diagonal is bisected, then both of those segments have to be the same. So it's going to be half of the whole thing. So half of 74 is 37. So WV is going to be 37 because that's half of 74. Then since WV is also 4x plus 1, I'm going to say 4x plus 1 equals 37. So I got the 37 from the definition of bisect. Then I'm just going to solve for x. And again, make sure you answer the question asked for. It said solve for x, so I solved for x, so I'm good there. So for 10 then, you're still using your diagonals, but you're using it a little bit differently. So 9, you use the fact that half of your diagonal you're using the fact that you get half of your diagonal since it's bisected. So for 10, you have that NS is 2x plus 7, and then that SQ is 5x minus 23. So before I put the marking saying that those two parts would be equal, so since the two parts are equal, we're going to set those two equations equal to each other and solve for x. So I end up getting that x equals 10. Again, you want to double check that you solved what it asked for. So it asked for NQ, so it asked for this whole diagonal length. So the first thing I need to do is plug it into one of these equations. So I'm going to plug it into the 2x plus 27. Sorry, 2x plus 7. Then I end up getting 27. So that means that half of my diagonal is 27. Well, if half of it is 27 and both of these parts are equal, so this part would be 27, and S is 27, and then SQ is also 27. So if I add those two numbers together, I'm going to get my whole length. So then NQ would end up being 54. So again, for these two properties, for these two numbers, you use the property that the diagonals bisect each other. And it used it in two different ways. So 9, you needed to understand that if the whole diagonal is one number, so if the whole diagonal is 74, then half of that diagonal is going to be half of the number because it's bisected. And then 10, use the fact that each part of your diagonal would be congruent to each other since it's bisected. So that's two different ways you're going to see problems that deal with the property of diagonals being bisected. So then let's move on and look at 11 and 12. So 11 and 12, if you notice, deal with angles. So it's the same type of setup as 7 and 8. So the property we're using is that the opposite angles are congruent to each other. So just like 7 and 8, when we set the sides equal to each other, we're going to set the angles equal to each other. So I'm going to say that 6x minus 15 equals 4x plus 11, and then solve algebraically. So subtracting my 4x and then adding the 15. And then divide by 2. Then again, you want to double check, did you answer what it asked? Well, it asked me to find the measure of b. So I'm not done yet. I didn't find b, I found x. Well, there's nothing there for b. It's blank. But what we can do is still plug x into one of these numbers. So I'm going to plug x into angle C just because that's what I feel like doing. You could do angle A if you want, it doesn't really matter. So I'm going to say 4x plus 11 is angle C. So 4 times 13 plus 11. So you get 52 plus 11 will give you 63 degrees. So angle C is 63 degrees. So then if we look at angle B and angle C. So I'm looking at these two angles, angle B and angle C. Those two angles are consecutive angles. So remember from our properties, consecutive angles are supplementary, right here. So that means those two angles are going to add to equal 180. So then what I can do is just subtract 63 from 180, and that'll give me what angle B is. So I get that angle B equals 117 degrees. And I'm good. So angle R, again, uses the fact that 12 uses the fact that P and Q are consecutive angles. Since they're consecutive angles, they're going to be supplementary. So I'm going to write my equation as 3x plus 5 plus 8x minus 12 equals 180. And then solve for x. So I want to combine my like terms so that I get 11x minus 6 equals 180. Sorry, minus 7. And add my 7 over, and then divide by 11 so that I get x equals 17. So again, you want to double check that you're answering what it asked. It asked me to find angle R, so I'm not done yet. But what we can do is, if you notice, angle P and R are across from each other, and those two angles will be the same measurement. So I'm going to substitute 17 in for angle P, because that'll give me angle R since they're across from each other. And we know that in parallelograms, opposite angles are congruent. So then I get that angle R equals 56 degrees. So 11 and 12 use the properties that deal with angles. So they use the property that opposite angles are congruent and that your consecutive angles are supplementary. So then last but not least, let's look at 13 and 14. So 13 and 14, we're still looking at angles, but one thing you have to understand for this is that since the opposite sides are parallel, then we end up getting transversals. So you have to utilize those angle pair relationships that we've learned in the past. So for 13 it says that KLH, so K to L to H, so this whole angle right here is 134 degrees. And then it also tells me that this little part over here is 25, and then this little part is 4x plus 9. Well, if I redraw this with the top of the bottom of my parallelogram, I'm going to draw the transversal that uses the diagonal HK, because that one is what those two angle touches. So like if I used JL as a transversal, that's not really going to help me because it doesn't use this expression or this angle measurement. But using this way, I can see that this one right here would be 4x plus 9 because it's to the left of that transversal. And then I can also see that this one right here is 25. So then what I can do is say in my picture that the other little part is 25. So this whole degree measurement right here wouldn't necessarily be 25 because we have the other end of the other side of our parallelogram intersecting it, but you can say that the opposite side is 25 degrees. And then if I have that angle L is 134, these two together so angle J and angle L, angle K and angle L are consecutive, so they should add to be 180. So I'm going to say 4x plus 9, so that first little one, plus 25 plus 134 should equal 180. And then I'm going to combine my like terms. So I'm going to get 4x plus 168 equals 180. And then subtract 168. So that I get 4x equals 12. Divide by 4. And I get that x equals 3. And it said just to solve for x. So this one was a little bit difficult because you had to notice where those other angles kind of connect. So you had to pull in prior knowledge from Unit 3 where we did those parallel lines with a transversal, and your angle pair relationships. So 14 is gonna be the same type of thing. So it tells you that A, B, C, so A to B to C, this whole angle is 115. So I'm going to redraw my parallels, and then since I'm just dealing with those two angles, I'm drawing BD as my transversal. So 4x plus 6 is to the right, to the left of the transversal, and 6x minus 11 is also to the right of your transversal. So then, just like before, we could take this 6x minus 11 and say it goes up there. You guys have to remember and realize that these aren't exactly the full angles, because I have, again, this one side of my parallelogram, so actually this goes through something like this, is the other side of your parallelogram. So 6x minus 11 is this full part right in there, this full angle here. But 4x plus 6 isn't that whole thing there, because if I extend BC and if I extend AD, what I'm looking at is it like this. So 6x minus 11 is still that full angle in there. But if you notice, 4x plus 6 isn't this full angle, because I have my side. 4x plus 6 is really this little part in here. But 6x minus 11 would still be alternate interior, so you could still say that it comes over to that other side. Comes over to the dark side. I'm not sure if this eraser is going to work. Yeah, it's going to erase the whole thing, so never mind that. Let's just take this away. Okay, so then this little part in here is also 6x minus 11. Well, it told us that ABC is 115, so these two expressions added together should equal 115, because it should equal that whole angle right there. So I'm going to have 4x plus 6 plus 6x minus 11 equals 115, and then you want to combine your like terms. So I'm going to have 10x minus 5 equals 115. Add my 5 over. And then I want to divide by 10. And I get that x equals 12. Again, you want to make sure you're answering the question it asked. So it asked for ADB. Well, ADB, A to D to B, is this part right here. So it was the one that had the expression 6x minus 11. So we're going to substitute 12 in for that expression. So 6 times 12 minus 11. Give me a 72 minus 11. So then angle ADB equals 61 degrees. So 13 and 14, out of all likelihood, will be the hardest problems, just because you have to be pulling in a lot of prior knowledge, and you have to be able to look at the pictures and see the relationships that the parts have. So you have to see the relationships between the angles and how they kind of move around your picture, and see what sections are equal to each other and kind of how they all relate in the big picture of the parallelogram. So these problems will get easier as we do them, but you still need to make sure you know those properties. So you need to make sure you know the properties of a parallelogram. So these properties right here. Again, from going through those problems, hopefully you noticed that the ones we used the most often were the 4 here that we were looking at. So again, as always, if you still have more questions that you don't understand, make sure you come during Monacan morning or during the after-school help hours. Hope you have a good night and dream about math things.